this, and here's an example, and I'm going to go through all the steps. So we're doing hypothesis testing, and what we're doing is we have a claim. So someone makes a claim, and then we take example. So we have claim, and then we have a sample, and we test that sample against the claim and find the probability that that would happen. So let's see, and find the probability that that example would happen if the claim is true, or if we call it the null is true. Do we keep the null or do we not keep the null? And that's basically what we're doing here. Okay, so here's my example. It's been reported that the average credit card debt for college seniors is at least $32.62. Okay, if the student senate feels the average credit card debt is less than that, so it conducts a study with the sample. I'm not going to write all the words out, but the sample of 50 seniors. They find that the average credit card debt in the study is $2,995 with population standard deviation of $1,100. And we're going to let alpha, the significance level, be 0.05. So it says conduct a hypothesis test. Okay, so again, let's read this again. It's been reported that the average credit card debt for college seniors is at least $32.62. The student senate feels the average debt is less than this, so it conducts a study with a sample of 50 seniors. They find the average debt in the study is $2,995 with the population standard deviation of $1,100. Let alpha equal 0.05. So that's our significance level. Yeah, this is a hard week, Robert, and the video that I sent out in the announcement should really help. It has 3 examples in it. We're doing the 3 cases, and then I did send out another example that had about 8 examples written in the text. So you really should look at all those examples and to see how each problem is done, because each problem is done the same way. It's just that there's 3 cases. So everything I sent out needs to be looked at for this week. This is the most difficult week. Next week is not this difficult. Okay, so we'll be easing up next week. Actually, next week is our last week of material because the final is a whole week. All right. So anyway, let's go through the steps. The first step is find the claim. Okay, so what's the claim here? The claim is that the student senate feels the average credit card debt is less than 3262. That is the claim. Okay, that's what we're going to test. So the credit card debt, the average credit card debt is less than 3262. That's what you have to find first. You have to read the whole thing and find the claim. The second thing you do is decide what are the hypotheses, the null and the alternative. Okay, before I turn the page, you can't get these mixed up. Don't mix up the claim with the example. Okay, that's really important. That's why you have to decide your claim first. Don't mix the claim with the example. So the example here, again, before I turn the page, the example is the 2995 and the population standard deviation of 1100. Don't mix those numbers up. This is the example. So again, the claim is that the average is less than 3262. All right. So how do you decide the null? And the first step is the claim. The second step, well, actually, this is all the first step, the null and the alternative. All right, here's another really, really important thing. The null always has the equal sign. So it's either equal, less than or equal to, or greater than or equal to. Okay, it doesn't mean that the null is always the claim. That's not the case. So no, that's not the case. This claim is not automatically the null. The null has the equal sign. The null and the alternative are opposite. So this turns out to be the alternative because it's a less than. So the the null is always equal, has the equal sign. Okay, so since this does not have the equal sign, it's just less than, that's going to be the alternative. So in this case, the null is going to be the mean is greater than or equal to 3262. And the alternative, and that's the only reason because it has the equal sign, is less than. Okay, so that's how you determine your hypothesis, and that's why it's important you write down the claim first. So write down the claim. Whatever has the equal sign with it, whether it's equals, less than or equal to, or greater than or equal to, is always goes with the null. Then the opposite is the alternative. So our claim here goes with all alternative, but it's not always the case. It could have been the null if it had the equal sign. Okay, second step is the alternative hypothesis tells you the tail, what tail it is. That's really important because you're always going to draw a picture. So since this is less than, this is left tail. All right, and then let me put in parentheses, if it's greater than its right tail, and I'll tell you, I'll draw a picture in a minute, and then if it's equal to or not equal to, then that's two tail. It'll never be equal to because that's the null. The equal goes with the null. So in step 2, the alternative is what tells you what kind of tail it is. So since this is less than, it's pointing to the left, it's left tail. Here's a picture. Okay, our claim, I always draw a normal curve, even though if it's a T problem, it's not quite it's not quite normal, but I always draw a normal curve just to get a perspective. Okay, in the middle is going to be your claim, the mean. So 3262 is the claim mean. And it's left-tailed, so I'm going to put this over here. It's going to go to the left, the part that you shade. This number right here is going to be your sample mean. And in our case, our sample mean was the 2995. So don't mix up the claim with the sample. It's really important. We're testing the sample against the claim. The claim is always in the middle. And it's, in this case, left-tailed. 4, alpha. Alpha is our significance level, and it's 0.05. This means there's a 5% chance of making a type 1 error. That means rejecting, we only want a 5% chance that we reject the null, but it's actually true. So we can set that at any number, but we just set it at 5 because 5%. Because in these tests, we can't prove anything. We can only get within 5% error. You're never going to get 100%. You can never prove everything because you can't test every single number. So we go with the 5%. That's a low enough error. So step 4 is we decide the significance level. Usually in all these problems, it's 5%. But they have to tell you that. They will tell you that in the problem. Okay, my step 5 is, what test is this? Is this a t-test or a z-test? Well, if you remember in the problem, it said the population standard deviation is 1100. So we know the population standard deviation. So since this is known, it's a z-test. If we don't know the population standard deviation, it's a t-test. So we know the population, and that's hardly the case in any problem. Yes, it's Z, Robert. Yes, very good. Since we know the population standard deviation. That's how you tell. Now, since it's Z, we go to the calculator. We go to the normal calculator, and we're going to find P, the probability, and I'll talk a minute about what P is after we find it. Okay, so I'm going to go to the, I'll share in a minute, online normal calculator, whichever one you like to use. Again, I like to use the one with the picture. Let me share it with you. Okay, so here's the calculator that we've been using. You just search for, it's onlinestatbook.com, onlinestatbook.com, normal calculator. And for the mean, we're going to type in the claim mean. Okay, so 3262 should be in the middle. And the standard deviation, we're going to use the central limit theorem. Okay, so let me go back a minute. I should have done that. The mean that we use is 3262. The standard deviation that we use is the population standard deviation in this case over the square root of n from the central limit theorem. So that's 1100 divided by the square root of 50. And there was 50 things in the example. Okay, so when you use your calculator, let's see. I get 155.563. Okay, so that's what you plug in. You can go right to the calculator. So again, I'm going to share the calculator and put in 155.563. And then since it's left-tailed, I want it below our example mean that we found in the sample study. So that was 2995. That's what you're testing against the claim. Now look at the picture. You get a left-tailed, 3262 is in the middle. The claim mean is always in the middle. And you test your sample mean. So we're testing the 2995. So your picture really shows you that. And then you get the probability that that sample is over there. It's only 0.043. So what we just found is that if the null is true, so always keep that in mind, if the null is true, the probability that we get a sample like we just did is very low. It's only 4%, 4.3%. That's what that probability, that's what P means. So if the null is true, the probability that we get the sample is really low, or anything more extreme. It's very low. It's point. So we were finding P. So P was 0.043. Now what you do is you compare P to the alpha for your 5%. So P in this case is less than alpha, which was 0.05. So if P is less than alpha, P is low, null must go. I just remember that little rhyme. It's easier to remember. If P is low, the null goes. If P is high, the null flies, which means it stays. But our P is low. It's less than 5%. So when P is low, the null goes, and that tells us that we reject the null. Remember what the null was, that the mean was bigger than 3262. That was our null. So just to remind you, because that was a while back. Okay, so that doesn't mean we proved it. Okay, you can't prove, we're only 95% sure. That's what that means. We can't be 100% sure, but we're 95% sure, and that's pretty good. So our conclusion, I call this step 8, conclusion, is that there's sufficient evidence to say that the true mean of credit card debt is less than 3262. So when we reject the null, we can say that it points to the alternative, but we can't say that it proves the alternative. All we can do is say is it points to it. 95% sure. Okay, if you follow those 8 steps, then and I put more steps in there, but it's the same steps that are in the reading or that's in that announcement. Same steps. I just put more in there, so hopefully it's easier to understand. But every problem is going to be the same. If you get your claim right, then you'll get the rest will follow. You'll get everything else correct. So it's really, really important that you get your claim right. Does that, and I'll do a t-test example, and I'll show you the same 8 steps. So since I can't hear, I'm going to go ahead and just go on, but if you need to chat with me. So this example, I'm just going to do 2 examples. Okay, I'm just going to read it. With the current level of communication resources for an online bookstore and project growth, a company will be able to provide satisfactory service of average connection time per customer that is no more than 13.5 minutes. Okay, so we're talking about an online bookstore. And current level of resources, well, actually communication resources, the company will be able to provide satisfactory service if the average connection time per customer is no more than 13.5 minutes. So it said, based on a random sample of 45 connections, so here's the random sample of 45 connections, would you recommend the company upgrades their communication resources? So I'm just going to say, should they upgrade? Oh, okay. So, sorry, I skipped a sentence. In the sample of 45 connections, the mean connection time was 15.3 minutes with standard deviation of 6.7 minutes. Okay, so this company, if they can connect in no more than 13.5 minutes, it's pretty satisfactory. In the example, though, the mean was 15.3 minutes and the standard deviation was 6.7 minutes. So the first thing we want to do is find the claim. Okay, this is the most important step. The rest of it is easy, really. If you get the claim right, then you can get everything else correct. So what's the claim here? Well, these 2 numbers go with the example. So we want the bookstore says that the average connection time is no more than 13.5 minutes. So this part right here, this number goes with the claim. So if you separate the sample with the claim, then you're on your way to the other 8 steps, other 7 steps or so. Okay, so no more than 13.5 minutes is satisfactory service. So that's what the company claims. Okay, even though the sample shows otherwise. So then we have to understand in math language, what is no more than? No more than 13.5 minutes. So that means you can't have 14 minutes, you can't have 16 minutes, you can't have anything more than 13.5. But it could be 13.5, so no more is less than or equal to 13.5 is what the words no more than mean. It means you can have 13.5 or less. So it could be less or equal to, less than or equal to. Now, once you get, well, we still don't have the hypothesis, but you have to translate, you have to learn how to translate these words into math. And no more than means less than or equal to. Now, since that has the equal sign, that tells you right away which hypothesis it is. So first you decide your claim and put that into math symbols. The null has the equal sign. So this is the mean is less than or equal to 13.5 is the null, and the alternative is greater than 13.5. They're opposite. So once you get one, the other one's opposite. And all you have to remember is the null has the equal sign. So the alternative never has the equal sign. And that's just a decision that mathematicians have made to make everybody, so everybody's test comes out the same. Or every test is set up the same. So once you decide your hypothesis, then step 2 is decide what tail it has. Well, the tail is decided by the alternative. And since it's greater than, it's right-tailed. The alternative is this one, it's right-tailed. So our picture, number 3 is our picture. I'm going to draw a curve, and then I'm going to put the claim goes right here. 13.5 is always in the middle. That's the claim. We always test the sample against the claim. The sample was 15.3, and it's right-tailed, so we shade to the right. So we want to find the probability that something's going to be bigger than 15.3. So it really helps to draw a picture. Okay, step 4 is to decide what alpha is. If alpha isn't given, well, I didn't write it down, but alpha is 0.05. Again, 5% chance of being wrong. 95% chance of being, you're pretty sure that you're right. That's your significance level. Step 5 is to decide what test it is. Now, since we have only the sample standard deviation, then that tells us it's a t-test. We don't know the population standard deviation, so we know it's a t-test. Now, you can't just, maybe you can find another calculator that you want to use, but I stick to the calculator that I like. So we have to use the formula where we take our sample mean, it's just like a z-score, minus the claim mean. Again, like I said, it's just like finding the z-score over the standard deviation divided by the square root of n. So we're going to do 15.3 minus, this is what t is, so we're going to find t. And you could have done this in the other problem. You could have found z and then used the calculator. Then in that case, you would use a standard normal calculator with the mean 0 and the standard deviation 1. So if you use this formula to find z in the first problem, it would still work. You could do that. Okay, our standard deviation, let's say, is 6.7 divided by square root of 45. So when you work this out on the calculator, you get 1.821. Then we go to our t calculator and find the probability that we end up in that shaded region. So I'm going to go to our calculator. I'm going to share my screen. And let's see. T distribution is number 12. So I know T is 1.821. Degrees of freedom is n minus 1. So with the T, we need degrees of freedom, just like with the confidence intervals. And I made a short video so that you understand what a degree of freedom is. And I sent that out in an announcement. But we do n minus 1. So we had 45 in our example. So we're going to use 44 degrees of freedom. Now, this is for two-tailed test. So what we have to do is we only want one side of the tail. So we're going to take this answer and divide it by 2. So if we had a two-tailed test, this answer would be fine. This 0.0754, that would be okay. But we only have a one-tailed test. So let me go back. We got that was two-tailed. We're going to divide it by 2 because we only have a one-tailed test. And we get, let me use my calculator. .0377. Okay, that's the probability that we would find a sample in that tail if the null was true. So that probability is so low that when we compare it with alpha, we find p is less than alpha. 0.0377 is less than 0.05. Okay, so p low, null goes. We again reject the null. So Number 8, there's sufficient evidence that the average connection time is greater than 13.5. Now, we did not prove it, but we're 95% sure. So it probably takes longer than average. So yes, they should upgrade. Yeah, yeah, it is right. It's right tails, but it's only one tail. So let me go back to the calculator. Sorry. I just saw your question. Go back to this calculator. See, that's answer though is for a 2-tailed problem, and ours is just 1 tail. Let me get a pen. Hold on. So that's why when you go back, oh, where did I get the degrees of freedom? N-1 degrees of freedom. It's just like with the confidence interval, same thing. Degree of freedom is N-1. So we had 45 in the sample. So degree of freedom would be 44. You only do that with the t-test. You only need degrees of freedom with the t-test. Okay, now Stephen had a question. Stephen had a question about assignment 6, and he's not here, and I don't know exactly what his question was, but I'm going to the written assignment 6 part 2. I'm going to kind of help you set that one up. And if you get the claim right, again, you'll get the rest of it right. So let me read through this, and then I'll answer any questions you have. Example of 51 homes for sale in the city showed a mean asking price of $258,000. So let's write everything to do with the claim here in the example here, so you don't get them mixed up. So the example had 51 homes, and the mean, well, that's not the example mean, X bar, you should write X bar, so I'll just write mean, so you don't get the symbols mixed up. $258,000 for the house. Again, this is the last question in the written assignment. But the city claimed, so they're telling you the claim, that the mean asking price was $249. So they're saying the mean was $249. So mean was, let me fix that. I'll just say mean is 249. That's their claim. The population standard deviation was 19,000. So I'll just write that down here. Population standard deviation, 19,000. So notice when I do one of these problems, I'm going to write all the information down and then decide how to use it. It says use the p-value, and that's what we're doing. We're finding the p. I'm not going to work this whole problem, but I'll help you set it up. So the claim is that the mean housing price is $249,000. Well, that means the mean is equal to $249,000. So what is that? Is that the null or the alternative? That's the next thing you pick. What is the null and what is the alternative? Well, the null always has the equal sign. Okay, so that is the null because it has the equal sign. So what's the opposite of equals? Well, the opposite is not equals. So it's either equal to 249,000 or it's not equal to 249,000. Now what that does, it tells you, so that's the first thing, decide the claim and decide, that's step one. The claim helps you decide what the null and the alternative is. The null has the equal sign, the alternative tells you the tail. So since the step two is tail, since it's not equal, the tail's determined by the alternative, then it's two-tailed. Equal and not equal is a two-tailed case. Since we know the population standard deviation, this is a z-test. Then the last thing I'm going to do is draw a picture. Put the claim in the middle. You're going to use the example to test the claim. This is two-tailed. So make sure when you find the probability that you make sure you get both errors. So the probability is this area and this area. So make sure you get both areas when you find the probability, and you use the z-test to do that. So hopefully this is getting a little easier. Again, the first thing you do is have to decide what the claim is. And I know Stephen left, but he texted me, and I'm not sure what his question was, but that will get you started on number 9, and that's what he asked me about. And I'm sorry I can't hear you, but do you have any questions? What was the formula? It's the same thing. You could, let's see. If you want to use the formula, then you use the standard normal calculator. So it's the same as for the T formula. The Z formula is the sample mean minus the claim mean over whatever standard deviation you have, in this case, population standard deviation of the square root of n. So the only difference in these formulas between z and t is this thing right here. If we know the population standard deviation is z. If we only know the sample standard deviation, then it's a t-score. Now, if you get this number, then you use the standard normal curve in your calculations. With the mean 0 and standard deviation 1, okay? So if you use that formula, then when you go to the calculator, let's see, I'll go to the normal calculator. Then you're going to use the mean to be 0, the 1, and then whether it's below, above, whatever, let's say it's below, since you found the z-score, that's what you would type in right here. You would type in whatever z-score you had. Okay, and that would give you the same answer as if you typed in the mean. Let's see, my first example was the example that I did. Let's use those numbers. It was 32. I'll show you it's the same answer. It was 32, 62, and then we did the standard deviation was 155.563, and then we did below 2995, and we got 0.4%. Remember, we got 0.043. Well, that would be the same. You would get the same answer. Let me go back to my whiteboard. As if you did this. Oh, the 155, that's the standard deviation of a square root of n. That was 30, that was, wait, what was that from that first problem? That was 1100 over the square root of n was 50. That was the first problem. That was 155.563. Okay, or you could do it this way, okay? Or you could find the z-score where you take your sample, 2995, minus the claim mean, I'm doing the same problem, over the standard deviation over the square root of n. So if you use this formula, okay, let me use my calculator. It's going to be negative. And then use a standard normal curve. So I'm going to go back to my calculator. I'm showing you I'm going to get the same answer. Okay. Before I used the mean, and then I did the standard deviation divided by the square root of n, and I said below 29995. I'm going to get the same answer if I actually find the z-score. So below negative 0.0343 and calculate that. And let's see, why am I off? I must have made a mistake in the calculator. Let me get my other calculator. I'm just trying to use my phone. Okay. All right, 2. Oh, all right. Yeah, I made a mistake. I made a math error. I'm sorry. I was using my phone calculator instead of my real calculator. Okay. This is minus 1.716.3 See, and I get the same answer, 0.043, 4%, 4.3%. If you look at that area, it's the same area as it was below 2,995. So if you want to use the z-score formula, then you can just do it this way. And then that'll match the t-score formula, and then you won't have to remember, which way to do which one. So if you want to do it that way, that'll give you the same answer. So let me go back and make sure you understand. You could either use the calculator with the mean 3262, the claim mean, and then use this for your standard deviation. And then I did below 2995, and I got 0.043 for the probability p-value. Or I could do the z-score and get this for z, and then go to the standard normal calculator, which means the mean is 0, standard deviation was 1, and then I did below negative 1.7163 because this is the z-score for that number. That's just the z-score for that number. And I got the same answer. So there's two ways to do the z problem. Just like with it's the same thing with confidence intervals. It was the same thing. Okay, so this was the 155.563. And again, the t formula is the same. It's the sample mean minus the claim mean divided by the standard deviation of whatever one they give you. They should give you the sample standard deviation for the t formula. That's the only difference. And then divided by square root of n. Same formula, pretty much. Then you just go to the t calculator. Okay, does that work? Okay, like I said, I am so sorry, wasted time in the beginning, and I'm gonna get this issue fixed. Maybe it's my laptop's pretty old, so it might be a problem with my laptop. Hopefully not. But if you need to get on with me this week, just let me know if you need to get on class again. Okay. Huh. Let me check my. See, the speaker volume's 100%. On my settings, I have. I will make sure I check this out. But if you need to get on with me again this week, just let me know, okay? Okay, and you can also text or call me. And I can help you that way. Okay, that would be fine. Okay, I hope you have a good night. I recorded this and I will post it tonight as soon as it's published. Because I know I went kind of fast, but if you do the 8 steps, you'll be in good shape, especially, trying to find the claim. But I will post this as soon as possible and then get my speakers fixed. Okay, well, have a good night.